Okay, let's do 1.82. Why not? Okay, so let's see what they're saying. Determine whether each function is even, odd, or neither. Circle one. So remember that in order to be even, we need to flip or reflect horizontally and end up with exactly what we started. In order to be odd, we need to reflect horizontally and vertically, then be back where we started. And if we're not even and we're not odd, then we're neither. Okay, so for that reason, I am first going to reflect all of these guys horizontally to see if they're even. And if they're not even, well, I'm already half of the work done to check if it's odd. So let's go see what I mean by that. Okay, I'm all about efficiency, you guys. Lazy, remember, the least amount of work possible. Let's see what we get. We'll do it in green. Let's see what we get when we flip this guy horizontally. So this part flips over this way. And then this part flips over this way. So did I get exactly what I had when I started? No. So it's not even. Okay. Now I got to check if it's odd. And flipping horizontally is one of the steps. So I'm already halfway to checking if it's odd. Now I just have to check if, what if I take the horizontal flipped one and flip it down or up, vertical, flip it vertically. So let's see. This part would flip down. And this part would flip up. And it does fall right back on top of what we started. So this one's odd. Okay, let's go see this guy. If we were to flip him horizontally, this part would flip this way. And this part would flip this way. And we'd have exactly what we started with. Even. Okay? I don't even have to check if it's odd. Usually a function is not both. However, just in your head, if you flipped it, it'd be upside down. It definitely wouldn't be the same. Okay, let's check this guy. Let's flip him horizontally. See what's going on. This little mountain would flip over to be here. And this little valley would flip over to be here. And we would just kind of have that. Okay, so not even. Didn't fall on itself. And then if I were to flip it vertically, all of this would flip up into the positive area. Okay, so it would be like, technically it'd be here, but you don't even need to, see, it's hard. I'm messing it up. You don't even need to graph it. It's not the same as what it was when we started. It's not that red graph. It's not. So it's not odd either. And this one is neither. Okay? Okay. Let's do our horizontal flip. This mountain will flip this way. This valley will flip this way. And then it'll keep going from there. So no. But now let's flip it vertically. So from here, flip it down. And everything flips right back on top of the original. That is an odd function. If you're curious, that's sine of x. Sine of x is odd. Okay. All right, let's go see what's going on here. You didn't need to know the sine of x part, by the way. Each graph shows half a function. Sketch the other half to create a function that's odd. Okay, let's see. I'm going to be odd, I must flip left to right and up and down. So I'm just going to flip this guy left to right. I'll get something that looks like this. And then I'll flip it up to get something that looks like that. Okay? Yeah. I mean, if we want to be exact, I should have gone all the way to the -5 line with this. Okay, so it should be more like that and that. Okay, however, when they say sketch, I mean, if you were off by that much, you're not getting points off for that. But yeah, really good. Okay, this is it. Now, even, we only want to flip horizontally. Okay, so I need this guy to flip. Then I need this guy to flip. And then I need that part. Okay, and that's an even function. And now, such a fun question. Okay, they want you to find the value of b. Oh, you can't see. Let's zoom out a little. They want you to find the value of b so that this function is odd. So remember, an odd function is when the original function f of x equals what we have when we do a horizontal flip and a vertical flip. And this formula is what I'm going to use, okay? Whenever I can use algebra, you guys, I do. I love to use numbers as opposed to just trying to picture things in my head, because I suck at picturing things in my head. Where the thing I'm interested in is b. And the only thing I know about b is it happens when x is 3. So that's a starting point. I can plug 3 in for x to get that f of 3 equals negative f of negative 3. Okay? And even though it may not look like it, we're almost done. Because f of negative 3 is something I can find from the chart. When x is negative 3, f of negative 3 is 4. Okay? So this portion right here, that's 4. Let's copy the rest of this down. F of 3 equals negative 4. And f of 3 is b. So b is negative 4. Okay? In order to be odd, remember, opposite x values need to have opposite y values. Okay. Now, if we want b to be even, we want f of x to equal f of negative x. So that means that f of 3 must be the same as f of negative 3. Okay? And f of negative 3 we already know is 4. So we need f of 3 to be 4. So we need b to be 4, which again, if you remember, in an even function, opposite x values have the same y value. So that's how that goes. Okay. Number 9. Sketch a graph of a function that's both even and odd. Holy moly. Okay, I had some thoughts about this. The more complicated a function is, that's not even a function, but you get what I'm saying, the harder it is to make it be even or odd, let alone both, okay? So the key for this one, what I was thinking was simple. Go simple. And the simplest simple I could think of was a point, just like a point on the origin. Flip it horizontally, it's the same. Flip it vertically, it's the same. It's not really, it's a function, kind of. It's not that special. So then I was like, if I make a vertical line, flipped vertically and horizontally, it's the same. So it's both even and odd. But then it's not a function. So finally, I landed on a horizontal line at 0. Okay, they only want the graph, so you're done there. But the equation is y equals 0. And this, when flipped horizontally, it's the same, so it's even. And then when flipped horizontally and vertically, it's still the same, odd. Okay? Here we go. Let's do some transformations here. Describe the transformation that moves f of x onto g of x. So how did f of x become g of x? Okay, let's do it. I see some flipping. Oh no, you can't see what I'm working on. Let's move it. I see some flipping. So the first thing I'm going to do is flip this guy from being up 2 on the y-axis. It would flip to be down 2 on the y-axis. And then this part would flip like this. And that part would go like that. Okay. So a vertical reflection is happening. Okay. Then it looks like if I just do a horizontal reflection, I'm there. So vertical reflection and horizontal reflection. Okay. And then they want the equation of g of x in terms of it. Well, once I've got these words, it's easy. Vertical reflection, that's a negative in the front. Horizontal reflection, that's a negative in the parentheses. Done.